So, uh, hi guys, welcome to Geography series, lesson 10. In previous classes, we have studied about geomorphology, that is continental drift theory, your endogenic, exogenic process, and how different landforms are evolved. And we have not studied about what are the different landforms that are formed. Okay, that's completely a factual topic, and we will look into it at the end of the physical geography series, like that is after climatology and oceanography. So as we are done with geomorphology, now we'll step into climatology, and after that we will go into oceanography. Okay, so yeah. So in today's class, we will just learn about basic concepts of climatology, basic concepts. Okay. In lesson two, that when I have taught you about uh, origin of the universe, we have also learned about the primordial atmosphere of the Earth, how atmosphere of Earth has evolved, what are the changes that had taken place due to solar winds and all. Okay, please revisit that class so that it will bring you a clarity for like how atmosphere has evolved. Okay, see, in primordial state, that is at the time of formation of the earth, that means the primitive form of the earth, the atmosphere is very dense. Okay, it contained only hydrogen and helium. Okay, and due to solar winds and low gravitational attraction of earth, this primordial atmosphere got disappeared. Okay, why? Because of solar winds and low gravitational attraction, the primordial you know atmosphere of the earth got disappeared, because the solar winds, as they are blowing towards the earth, they disrupted the hydrogen and helium, that is the thick atmosphere that is surrounding the earth, that is hydrogen and helium. And while they are disappearing due to low gravitational force of the earth cannot hold them. Okay, earth did not have enough gravitational attraction to hold them together in that place. uh, and because of that, those gases are held in a very weak position, and those weak positioned gases were disrupted by solar winds that are emanated from the solar surface. Okay, and after the you know removal of hydrogen and helium, what has happened? Cooling of the earth happened. Okay, once the cooling of earth happened, the crustal portion, the crustal portion got uh, uh, it got cooled. Once it got cooled, it is very hot before that got cooled. Once the temperature started coming down, the crustal portion got cooled and emanated some gases into the outer surface of the earth. This process is called degassing. Okay, like if you take any hot object, like heat up a iron rod and put a ice on it. uh, okay, once the temperature goes down, the the iron rod starts releasing some gases. Okay, like I mean vapor. Okay, that's how degassing happened. The very hot portion of the crust got cooled down and released some gas into the outer surface of the earth. That is called as degassing. Okay, after that, volcanoes started taking place. Okay, these volcanoes also released some gas into the atmosphere. Okay, due to degasification and volcanoes, you know uh, the atmosphere started forming. The initial atmosphere, that is not primordial. After primordial atmosphere, that is primitive, after primitive atmosphere, The initial atmosphere that has formed contain mostly of water vapor, carbon dioxide, and sulfur dioxide. Okay, the initial form of the atmosphere. Okay, and after that, due to gradual process like filling up of oceans, precipitation, and genesis of plants, the due to process of the photosynthesis, due to all this process, today we have atmosphere of different layers. Okay, primordial atmosphere that has been disrupted due to solar winds. After that, degassing happened. After degassing, our atmosphere consisted of water vapor, carbon dioxide, and sulfuric gases. And after that, due to various processes like you know uh, photosynthesis, filling up of oceans, and precipitation, we have we an atmosphere with different compositions and layers has been created. That is the atmosphere we are seeing today. Okay, and okay, yeah, I mean, sorry guys, my webcam is not my webcam is not working properly, so that I have to remove the video feature, and it will not happen from the next class. All right, now we will look into what atmosphere is. Okay, an atmosphere of different layers is formed. What does atmosphere contain? Okay, uh, air is an integral part of the atmosphere. 99% of atmosphere consists of air. 99% of atmosphere consists air. Okay, um, and mo most of the atmosphere, that is almost 90% of the atmosphere consisted to 32 to a height of 32 kilometers from earth. Okay, most of the atmosphere is it is confined to 32 kilometers from the surface of the earth, major part of the atmosphere. Okay, what are the constituents of atmosphere? What does atmosphere contain? you know uh, Atmosphere mostly contains gases, water vapor, and dust particles. Okay, the major constituents of atmosphere are gases, water vapor, and dust particles. Okay, yeah, like we all know that most 98% of the air is of nitrogen, and after that nitrogen we have large quantities of oxygen. After oxygen we have large quantities of carbon dioxide. After carbon dioxide we have large quantities of argon, and remaining remaining percentage consists of helium and ozone and water vapor. Okay, water vapor is also a gas, guys. Okay, most of the atmosphere consists of gases of nitrogen, oxygen, carbon dioxide, and argon. Remaining percentage of gases is of helium, ozone, and water vapor. Okay, from this, um, we don't use nitrogen for our sustenance or for our survival. Okay, But most of the plants require nitrogen for their photosynthesis process, or for their survival. Okay, and plants take up nitrogen through a process called as nitrogen fixation. And oxygen, humans breathe in oxygen and release carbon dioxide. Okay, carbon dioxide. Carbon dioxide is, it is breathed by plants, and the plants release oxygen. They breathe in carbon dioxide and releases the oxygen. Okay, but this carbon dioxide is a major greenhouse gas. Why carbon dioxide is a major greenhouse gas? Because uh, you know sun, the radiations from sun reach the earth. Okay, the carbon dioxide molecules present in our atmosphere are transparent to solar radiation. Okay, transparent to solar radiation. Carbon dioxide molecules are transparent to solar radiation. Okay, this part of solar radiation, some part is absorbed by the earth and radiated back into the atmosphere. Okay, and CO2 is opaque. Opaque means non-transparent body. That means opaque means, if something is opaque, uh, the rays cannot pass through it. Okay, so CO2 is opaque to um, terrestrial radiation. The radiation that's coming back from the earth is called as terrestrial radiation, and CO2 is opaque to terrestrial radiation. Transparent, opaque. Okay, as the CO2 molecules absorb some terrestrial radiation and reflects back to earth, it acts as a greenhouse gas. Okay, greenhouse gas means, I will explain it later what greenhouse is. Okay, CO2, you just remember that CO2 molecules are opaque to terrestrial radiation. That means they absorb the radiation that's coming from the earth, and sends it back to the earth. So it cannot, the radiation coming from the atmosphere cannot escape into the outer atmosphere. Okay, the radiation coming from that surface cannot escape into the outer surface. So because it was absorbed by the carbon dioxide molecules present in our atmosphere, so that's why it is heating up our earth. Carbon dioxide is heating up our earth. Okay, and after that, ozone. We all know that ozone absorbs UV rays and protects us from harmful UV radiation. Okay, this is about gases. And water vapor. Okay, water vapor. The amount. Okay, here, once coming to water vapor, we are going to learn about a word called humidity. What is humidity? The amount of water vapor present in the atmosphere. Okay, as we move from equator to poles, humidity decreases. Why? At equator, um, there is more water vapor in the atmosphere. At poles, there is less water vapor in the atmosphere. Why more water vapor is present at equator? Because at equator, there are large number of equator is surrounded by large number of oceans. Okay, water molecules gets into atmosphere. And though there are more oceans at the poles, they are mostly in the uh, ice form or glacial form. So less water vapor in the atmosphere. As we move from equator to poles, humidity decreases because the amount of water vapor present in the atmosphere decreases from equator to poles. Okay. And another significant feature of water vapor is water vapor absorbs incoming solar radiation. Okay. Water vapor absorbs incoming solar radiation, unlike carbon dioxide. Carbon dioxide absorbs outgoing terrestrial radiation. Water vapor absorbs incoming solar radiation, thus acting as blanket for earth, like a hot blanket for earth. That is why the equatorial regions or tropical regions are more hot compared to temperate and polar regions. Okay. And moreover, water vapor contributes to stability and instability in air. What is stability and instability? Okay, as we move from uh, surface of the earth towards the atmosphere, we can see drop in temperature. If drop in temperature of air, this means the air is stable. As we move from lower position to higher position, there is drop in temperature. So we can say that air is stable. But if from surface of the earth to upper atmosphere, if there is rise in temperature, we will say that air is unstable. Okay. How water vapor contributes to stability and instability of air, we will look in subsequent chapters when we come into like precipitation and all. We will look into it. Okay. And next, dust particles. Okay. Sources of dust particles are soot, ash, and many other like pollen, etc. They are all sources of the dust particles. Okay. um, these most of the dust particles are present in lower layers of atmosphere, and they are hygroscopic in nature. That means hygroscopic means they are attracted to water molecules. Okay. If this is a water molecule, dust particles surround it like this, because they are hygroscopic nuclei. By nature, they are attracted to water molecules. Okay. And this makes water molecules condense. Condense means it makes the water molecules thicker and helps in precipitation. Helps in precipitation. These are the basic concepts. You have to remember them. Dust particles surround the water molecules and they help in precipitation. Okay. And moreover, dust particles are higher in concentration in temperate and subtropical and lower concentration in equatorial and polar. Okay. Again, what is equatorial region, what is temperate, what is polar region, we have discussed in the first class itself. While we are learning about latitudes and longitudes, I have taught you about equator, tropical regions, temperate regions and polar regions. Okay. Now coming to dust particles, they are higher concentration in temperate and subtropical regions because of the dry winds. Okay, the winds are dry. That means the winds does not carry water. So the dust particle does not wash out. So higher concentration of dust particles in the temperate and subtropical region. Lower concentration in equatorial and polar region. Why? In equatorial there is more rainfall. Why? We'll look into it subsequently. Okay, more rainfall in the equatorial region. So dust particles wash out. Okay, in polar region. In polar region, due to less water vapor, unstable air, okay, no vertical movement of air. So dust particles does not rise up. Okay, polar regions have less water vapor. Due to less water vapor, you know, the air gets unstable. What is stability and instability? I have explained it to you. Air becomes unstable. Whenever the air is unstable, there is no vertical movement of the air. That is, air does not move up. So the dust particles lying on the lower surface of the polar region does not come up. So there is less dust particles in the polar region. Okay, yeah. And after this composition of the atmosphere, uh, we learn about like basic concepts of climatology, like about pressure and temperature, pressures and temperatures. Okay, see, if there are more particles in a certain region, there will be more pressure and more temperature, because the particles are tightly packed. They are tightly packed. Because of this, there will be more more pressure and more temperature. All right. So and whenever there is more temperature, what happens? The particles get unstable and they move to surrounding areas. Okay, they move to surrounding areas. So what happens after they move to surrounding areas? There will be, you know, low pressure is developed there. Okay, uh, there due to more temperatures, particles get unstable and they start moving to surrounding areas. Okay, that is from high temperature regions to low temperature regions. And whenever they move, the what happens whenever the particles scatter apart, there will be low number of particles, and therefore the area will develop a low pressure. Okay, due to high temperatures, low pressure is developed. How? Due to scattering of the particles induced by the high temperatures, the particles scatter apart and develops a low pressure in that region. Okay, and next, and what happens in, like, whenever there are cool particles on the in the atmosphere, they are cold, that is dense. Cold means dense. What happens to dense particles? They move downward and develops a high pressure region here. And whenever there is high pressure region in one area, the particles move to low pressure areas. Okay, the cold air comes down and descend and develops a high pressure. After developing high pressure, particles move from high pressure to low pressure. So we can say that, uh, based upon this, high temperatures lead to low pressures, and we said air is cold here, so low temperatures lead to high pressure, right? And I have said here that the particles scatter apart, so there are less number of particles, low pressure is there, and the air moves from low pressure to high pressure. Sorry, this is other way. The air moves from surrounding high pressure to low pressure. So whenever there is high temperatures and low pressure, converging happens, converging of air. And whenever there is low temperatures and high pressures, diverging of air happens. Okay, this is about, temperatures and relation between temperatures and pressures in climatology. And after that, convection. What is convection? Movement of particles from high temperature region to low temperature region. Okay, see, imagine there is a water in this bucket, and you kept fire under this fire. Okay, what happens after you light it, like heat it up with a fire? uh, this lower part gets heated up and moves upwards to colder region. Okay, the heated part, the lower part gets heated up and it becomes unstable, and whenever particles are get heated, they develop a tendency to move to colder regions. Okay, um, and move upwards into colder area, and particles in colder areas move downwards. There is a a convectional current happening here. We have studied the same convectional currents in, you know, continental drift, rising of magma, spreading apart, converging and diverging and all. Same here, due to convection, the waters from hot area move to colder areas, and cold area move to hotter area, so that all the complete particles present in it reach a equal temperature. Due to this convection, due to convection, all particles achieve equal temperature. Okay, the same thing happens with the air. Whenever you are going upwards, when while going up, okay, we see hot air at the bottom and cold air at top layer. Okay, this is a stable condition. Okay, due to this stable condition, convection happens. Due to convection, what happens due to convection? Hot air moves up. Okay, whenever the hot air moves up, there will be a vertical movement of the air. Right. Whenever there is unstable condition, unstable air, that is cold air below, hot air above. Okay, no convection. That means no vertical movement. So, whenever there is a unstable condition, that is cold and hot, what happens in unstable condition? Conduction happens. Conduction means there is only transfer of heat from high temperature to low temperature. Okay, there is only transfer of heat here from hotter to colder area, that is conduction. Okay, and another two terms, reflection, radiation. Okay, yeah. What is reflection and what is radiation? See, there is a wall here. Okay, I hit the wall with a light. Okay, and this light traveled in a long wave fashion. Long waves are there. Okay, this wall reflected back the light. Reflected the light particles back. Okay, and the reflection is also in the long wave form. Okay, so what is reflection? Whenever something sends back to us in the same form, that if I hit a wall with a long wave radiation and it reflects back in the same long wave form, it is called as reflection. Okay, so and what is radiation then? Radiation means uh, the returning of particles is not similar to original one. Okay, see, whenever uh, s- uh, um, sunrays come to earth, you know, they come in form of short wavelengths like this. Okay, and earth does not reflect the sun rays. Okay, earth absorbs them and transmits some part of the sunrise into atmosphere, and earth does not reflect, it radiates back. Okay, earth absorbs the sun rays and radiates back into the atmosphere in the form of long wave radiation. Okay, so solar radiation is solar radiation is short wavelength. This is symbol for wavelength lambda. And terrestrial, that is the ones that is getting radiated back into atmosphere, is long wavelength. Okay, yeah, that's difference between reflection and radiation. Why short wave and long wave? Because uh, whenever sun rays are reaching to the earth, you know, the difference in the temperature. See, if there is 100 centigrade body and a like 25 centigrade body, this is high temperature and this is low temperature. uh, re- uh, you know, like heat energy passes from high energy to low energy whenever there is a difference of 75 degrees centigrade. Okay, whenever there is more is the difference, the more faster the rays travel. So more faster the rays travel, they will be in a short wavelength. Wavelength means distance between each wave, so the wavelength will be shorter, so the short wave radiation will be there between the bodies having the more temperature difference. And similarly, there is 100 degree centigrade body and 50 degree centigrade body, the difference is lesser, so waves travel slower. Long waves, wavelength is longer, long waves. So whenever sun is you know, sunrays are hitting the earth, the difference between them is more, so that waves travel faster. And whenever the earth is radiating back, the difference between the atmosphere and the, I mean, like outer space and earth is less, so that the radiations travel very slow in the form of long wave radiation. Okay, next, advection. Advection is nothing but horizontal movement of air. I have just explained that uh, if there is a low pressure, air from high pressure comes towards low pressure and there is convergence. Whenever there is high pressure, air diverges into low pressure areas. This horizontal movement of air is called as horizontal, is called as advection. And due to stability and instability, there is vertical movement of the air. Okay, vertical due to convection. Yes. Yeah. These are the basic concepts of temperatures and pressures. Okay. In next class, we will look into structure of atmosphere, solar budget. Okay. Yeah. That's all for today. Thank you.